Hello, and welcome to this GeneMarker HID introductory webinar. My name is Adam Dillman, and I am a biologist at Soft Genetics. GeneMarker HID is an expert system for forensic profiling of human STR samples. In addition to automated size and allele calling, GeneMarker HID has built-in relationship testing and kinship analysis applications, a database search tool, and manual and automated pedigree construction. GeneMarker HID is equipped with a mixture analysis application and also has an integrated user management system with a built-in audit trail and customizable access rights. GeneMarker HID is compatible with all major CE instruments and file types and supports all major human identification chemistries as well as custom chemistries. GeneMarker HID is compatible with Windows XP, Windows Vista, Windows 7, and Windows 8. I'd now like to demonstrate the typical workflow of GeneMarker HID. First, though, I will show you the features of user management, which can be accessed by going to Help, User Management. Under the User Manager tab, we can see a list of user accounts, and by clicking on the History tab, we can see a history of user login and logout attempts. To the right, you can add a new user or modify user access rights. These rights limit what a user can and cannot do when using the program. You can add an organization name, and finally, clicking the Run User Protection box will require users to validate themselves with their username and password before they are able to enter the program. Now, to import your raw data files, navigate to File, Open Data. Click Add and navigate to your sample traces. Select your traces, then click Open and OK. We can now see that the raw data has been successfully uploaded. Sample files are organized in a file tree to the left, and you may notice that my ladder samples are highlighted in blue. This is because in the View Preferences window, under the Forensics tab, I've entered ladder as my ladder identifier. Thus, samples with ladder in their file name will be labeled as allelic ladder samples. To zoom in on the sample trace, draw a box from left to right. You can scroll by holding down the right mouse key and dragging the mouse from left to right. To zoom out, just draw a box from right to left. You can show additional traces by simply double-clicking on that trace's file name. You can hide traces by simply double-clicking on the file name again. You can scroll through dye colors by clicking on the dye color icon, or view all dye colors simultaneously by clicking on the Browse by All Color icon. To process your data, click the green triangle icon in the upper left-hand corner, or go to Project, Run. Select your genotyping panel, your size standard, and your standard color, or simply select your pre-saved template. The second page has a variety of parameters that correct CE artifacts and govern how size and allele calls are made. Marker-specific settings can be accessed through the Panel Editor tool, which I will demonstrate shortly. The default settings are compatible with most analyses, and thus I'll simply click Next. In the last page of the Run Wizard, you can manually select your allelic ladder sample, or select Auto Select Best Ladder. With this option selected, the program will automatically identify the best ladder for each sample. This is particularly useful when using multiple ladders, as I am here. Check the Auto Panel Adjustment box to have the program automatically align the genotyping panel with your ladder sample. From this alignment, the program will create a new Shifted Project panel. When you have made your selections, just click OK. We can see that size calling was successful from the green icons to the left of each trace. Yellow and red icons indicate that samples could not be accurately sized. To visually review size calls, click on the Size Calibration icon. This window allows you to verify size calls at a glance. Here, for example, we can confirm that the pattern for each sample is very linear, as expected. We can also see that each ladder sample is now in bold. This indicates that the ladders passed and were used to create a new project panel, which was aligned to each ladder. Because I have two ladders, two project panels were made, Furthermore, we can see which of these project panels were used to make allele calls for each sample by simply noticing the reference ladder label in each sample name. For example, this sample used reference ladder _3, whereas this sample used reference ladder _1. Allele calls are summarized in the report table to the right, and a similar color scheme is used. A green icon means that a peak passed all analysis parameters. A yellow peak means that a peak is in the check range for at least one parameter, and a red icon means that the sample failed at least one analysis parameter. To customize the report, click on the report settings icon here. The report can be saved by clicking on the save icon as a text file or an Excel file. Table navigation is linked to the electropherogram. Simply double-click on an allele call to be taken to its corresponding peak. This aids tremendously in investigating flagged allele calls. For example, I'll click on this peak that has been flagged yellow. You can pull up more information about the peak by clicking the Show Chart Table icon here. Here, among other details, I can see that the quality status is check, and that the quality reason is IMB, or heterozygous imbalance. Peak quality reasons are given in the upper right under the Help drop-down menu. We can see from the flagging on the peak and from the height ratio in the table that the smaller peak is 57% the height of the larger peak. To get a better understanding of why this peak was flagged, we can navigate to the panel editor, which is under Tools, Panel Editor. Our list of panels is given in the file tree to the left, with our project panels being displayed at the top. Note that I have my original identifier and my two project panels, which have been aligned to ladder _1 and ladder _3 respectively. In the center is my electropherogram, and more information about the selected panel is displayed below in this table. To access marker-specific settings, simply right-click on a marker. My flagged peak was in D8S1179 here, so I will edit this marker. Simply right-click on the name of the marker and select Edit Marker. Here I can set the minimum acceptable homozygote and heterozygote peak intensities and set the stochastic range for each as well. Below you can also set the inconclusive range for heterozygous imbalance. In this case, if the smaller peak is between 20% and 60% the height of the larger peak, it will be flagged. Peaks lower than 20% won't be called, and peaks higher than 60% won't be flagged. We can now see that our selected peak was in the check range and thus was flagged. Just as an example, if this value were set at 55, we can see that the peak is no longer flagged. As another example, I'll select this peak, which has a red allele call. I can see here that the quality reason is OB and IMB, which stands for out of bin and heterozygous imbalance. Because of the size and shape of this peak, I suspect that it might be the result of some kind of spectral overlap. To check this, I'll take advantage of the All Color browser. Zooming in on the peak, I can see that it does indeed share its location with a very high saturated green peak. Thus I feel confident that this is not a real peak and that it's simply the result of spectral overlap. To delete it, I can right-click on it and simply select Delete. Note that even though I've deleted the peak, GeneMarker HID's running audit trail still notes its presence and notes that it was deleted. If necessary, I can undelete it by simply right-clicking on it and selecting Undelete. If you're interested in creating a print report, you can do so by simply clicking the printer icon in the upper left-hand corner. This opens the Print Report Settings window, which allows you to choose which samples, dyes, and other options you'd like to include in the report. As you can see here, the print report contains the electropherogram, and in this case, I've chosen to have the dye colors shown separately. The report also contains an informative header with the project name, software, and template. You can see that user management is also integrated into the header through the inclusion of my organization name and my user account. These reports can be saved as PNG images or printed directly. You should now have a good idea of how to get started in GeneMarker HID. After all allele flags like these are addressed, you can move on to post-genotyping applications. GeneMarker HID offers applications for paternity testing and pedigree construction, database searching, kinship analysis, and mixture analysis. Each of these topics is the subject of its own webinar, which I encourage you to watch. Thank you for watching this GeneMarker HID introductory webinar. For more information, or for a free 30-day trial of GeneMarker HID and other SoftGenetics products, please visit softgenetics.com or email info@softgenetics.com. For technical support questions, please write to tech_support@softgenetics.com. Thank you for watching.